Yeah, we're going to get started here with the next session, which is where and how do we build our app. It's me again, Sebastian, and my colleague Philip, who you've also seen earlier today. So I'm going to use this one as well. The purpose of this session is to open your eyes to specific problems that could occur in your build or development process. And the point is to make you think about if you really know the details of your process. We will ask a lot of questions, not answer all of them, but the point here is that those questions that we don't answer, you should go back home, back to work, and think about how your specific project solves this problem. And if not, you should probably map it up to try to solve them. It's like everything else, I guess, based on real-world experiences. It's based on a true story from auditing and building somewhat secure or secure systems. It's going to be quite fast-paced. You can stop us and ask questions if there's anything specific. Just as a quick note, there are several processes and models for secure development that you can have a look at. For example, in this case, the Microsoft SDL, that is thought through somewhat process for developing software from just training up to having a response plan. We're going to talk about something similar, not up to the response plan, but almost. Start by asking yourself, though, what is it you need to protect in your development and build environment? Depends on the project. Perhaps it's the source code. If it's open source, it might not be that secret, but you might want to protect that. Your cryptographical keys, where are those? Are they something you need to protect? Your specifications of your protocol, your domain logic, stuff like that could be secret to your project. Your network protocols, even if they can't be fully protected, as we've shown earlier, they might as well be, some of the obfuscation could be something you want to protect. And you might have other intellectual properties or documents. In some cases, you want to protect your brand and, I guess, your livelihood. So we're going to talk about a simplified view of the development process. That's somewhat true, I guess, for most projects. Starting with bootstrapping, that is just setting up the project up and including to running the actual code somewhere. And the security in each of these steps depends on your build environment. Yeah, Philip.
Yes. So I'm just going to very quickly go through a bunch of things that you should think about before you start actually developing. So, like setting up your environment. And this is kind of a repetition of what Emil showed us in the previous session. So, as a developer, one of your most important tool is your computer, of course. So you need to really take care of that. And as Emil showed you, if you lose your laptop, someone gets full access to it. Setting a password does not help you. You have to encrypt all your hard drives, full disk encryption. This is super easy to do, not only on OS X, but also on Windows and Linux. So you really should do this. And this might sound a bit silly, like something you tell your kids, but you really shouldn't just browse random websites and install apps and maybe plugins for your IDE and stuff like that. Really think about what you install on your development machine. And actually, a while ago, HP, Hewlett-Packard, accidentally signed malware using their official keys after one of their developers got infected by a Trojan. So this was the same keys they used to sign drivers and other software. So they had to revoke the keys and re-release a bunch of software, and that's really no good. So be careful. And again, as Emil showed you, you should really use a standard user account if possible. And use virtual machines for development. It's really nice to increase security. You get nice, you can separate your different projects and tasks, and you get them isolated. And you also get a bunch of other nice features that using virtual machines, provided you can save states in copy machines and stuff like that. So it's helpful in a lot of cases, not only to increase security. So just a few things to think about before actually starting development. Okay, so now you're getting to work on some actual code. You're working in a team, probably. This brings us to our next point here. It's a bit hard to read there. It's collaboration. When you collaborate on a project, often you have service involved. It makes it easier to collaborate if you have some common point where you can exchange information and source code and stuff like that. Are these servers exposed on the internet? Probably, somehow, even if you don't think it. You've seen various ways that an attacker can get into your network and get access to internal servers. So you really need to make sure that your servers are patched and updated, and that includes all software on all your servers. That includes Git and the shell version you use and everything really. And you need someone who's responsible for this. You can't just do this like once a year, just run sudo apt-get update or whatever.
No, don't just. Sorry, am I muted? Sorry. Don't just wing it. Have someone responsible and make sure
you need a clear process for this.
Yeah.
Someone needs to be responsible for updating your stuff. And using a VPN will or can increase security when you connect to your servers, but only if you use it as an addition to other security measures. If you just use a VPN, it will just become like a super highway right into your network, and that's really bad. Okay, more specifically, collaborating on source code. This is mostly about access control, really. Who can access your repositories, assuming you use some kind of version control system. And if you don't, you probably have bigger problems. But who can access this? Who can read stuff from it? Who can update? Who can push it to branches that are built and used in production, maybe? And if you maybe think you have a private remote repository somewhere, perhaps at a third party, maybe you have a private account at GitHub that you collaborate with other people on, it might not be as secure as you think. Here's a screenshot showing an attacker who managed to commit something to the Ruby on Rails repository on GitHub. And this was made possible through a bug in GitHub that made the attacker was able to add his public key to the trusted keys for this project, and that gave him access to the repo. So, yeah, you really need to think about how you handle your access control and who has access to what.
Yeah, moving on quickly, ask yourself or ask your colleague, does anyone review the code? Just a show of hand, who here has a clear code review standard in your work environment? Well, quite a few. Even if you ask yourself, even if you say yes here, do you know that everything is reviewed? Do you review the code before it's pushed, before it's merged? Do you review it weekly? How do you do? How do you do this? All the code should be reviewed, and this may sound like something a security type would say, and it is, and it's for a reason. It really helps your project to have code reviews for all the lines of code. And this is not just to find security holes, it is also to spread the knowledge of the source code, because you get more eyes on the source code and you make everyone see bits of the whole application. So I can't really stress this enough. It may sound expensive, but I mean, just having a review after having done the implementation is amazing. It's like pair programming, except it works. So you need accountability for the changes, and you get much of that by having a review process. For example, I don't know if anyone here knows about the Linux 2003 backdoor attempt, where someone attempted to, or actually managed to update a CVS clone of the BitKeeper original repository for Linux, and there they added a backdoor attempt where they actually removed an equal sign in a comparison, making the user root. And they found out this when it was synced, or rather when it was checked against the BitKeeper repository. They saw a commit that didn't belong there. So it never got into the main repository, but to a clone. But you need to have accountability for changes. And Git and other distributed version control systems make this way more easy, because the history is everywhere. So it's very much easier to notice if something has changed. You can't just rewrite history in an efficient manner in Git, for example. So mandated code reviews save lives, literally. And just going back to the fact that Git and many other systems like Mercurial store history forever and everywhere, don't push your secrets because you can't erase them. This happens every now and then, and attackers will look for your Amazon credentials if you push them to GitHub. So even if you force push a history change within the hour, it's still too late because it's out there. Moving on to integrating third-party code. This is very important. Do you trust your third-party libraries? Do you even know which third-party libraries you're using? Hopefully, because they can become your weakest link. And each library will increase your attack surface very much. And the library will have access to your user's data as well, because it will be running in the same process most likely. And you not only do you trust the libraries that you use, you also trust the libraries that those libraries trust, etc. I mean, just looking at Maven dependency tree for something including, in this case, well, it's a contrived example because I'm using the JBoss Java EE specification, so you're bound to get a lot of stuff. But you normally have a huge amount of dependencies that you're using in your project. Ask yourself, do you really need all that code? Do you need this huge utility library just because you want a base 64 encoder or something? Probably not. This is extremely important. Do you check for vulnerability? Is there anyone who checks at least once a week for vulnerabilities in the versions that you're running? Who's responsible for keeping up to date? Because this is like the #1 problem most often with projects. They have known vulnerabilities in third-party libraries. And it's such an easy way to attack your system if you don't update. And large frameworks often have large bugs, and you will be able to just browse vulnerability databases and find out nice ways to attack your system. So you need to have a clear somewhere where you state the exact versions you're using, and someone who is responsible for checking for vulnerabilities, or sign up for mailing lists or whatever. Do you even know which versions you're using? This is pretty common, actually. People not even knowing which version they're using. Maybe they're using one version in the developer machine, using one version in the build server, and then a third version when they ship it and run it in the client system. Sometimes we even see horrible things like you can do with go-get or Rust, where you can just download some GitHub repository and get the latest version and run that. I don't ever want to see stuff like that. You need to actually really know which version of your code you're running. Really. And that includes some weird fork that some guy made to fix some sort of issue. Do you really know that you can trust all that code after you've used that fork? I mean, you can see people providing forks to fix issues in, for example, small issues in, for example, building OpenSSL for a specific platform. Do you really trust that OpenSSL implementation after that? And who's behind the project? Are you using some sort of product that hasn't even been maintained for 3 years? So you maybe won't even get public vulnerability lists. They just have open vulnerabilities that are simple to use, to utilize. So you need to know that these projects adhere to your security requirements, and you need to know who's behind the project and who can contribute to the project. The GitHub pull request mentality is great for open source. It's also pretty dangerous if the one responsible for the open source project, for example, doesn't really check and vet all the things that get pushed to those repositories. And also example code can be extremely dangerous. We talked about this earlier from Stack Overflow and what have you. And I would like you really to repeat after me, but it's a hard thing to repeat. Stack Overflow is not a cheat sheet. This is a weird sentence, just saying it out, but it's true. Please do not just copy code from Stack Overflow. Try to at least read it, rewrite it, and make sure it's correct. Because, I mean, this goes for even best practice sites and like curated expert examples, maybe even stuff we put up sometimes. They occasionally get it wrong. We get it wrong. We found errors, for example, in OWASP security recommendations. An XML parser that tries to disable external entity parsing, like I talked about earlier. Instead, in the example, they explicitly enabled it, even if it was disabled. The iOS custom cert validation pinning example forgot to call the superdelegate method, so you didn't get any hostname validation. This kind of stuff happens even in the vetted examples. You need to keep your eyes open.
Okay, so you've decided which third-party libraries you trust. Now it's time to manage them, manage your dependencies. So, well, the big question here is how and where do you get your libraries? Do you trust the source? Is it available over a secure connection, or maybe just HTTP versus HTTPS? Do you maybe use some kind of local repository manager to handle your dependencies? Is that secure enough for you? And when you download your dependencies, do you verify the contents? Do you have package signatures? Are they signed by the author? And a lot of times you get a hash or a checksum, but remember that is not a signature. It doesn't prove anything. It's just an integrity check. And most dependency managers have questionable security. These weren't built to improve security. They were built as a convenience.
You could say that most dependency managers, in their default setup at least, have questionable security.
Of course.
And that's the point of this example.
For example, they might allow you to connect over HTTPS, but they maybe don't validate package signatures or something like that. Anyway, this is a really good way to for someone with malicious intent to get to you, which brings us to a possible attack, cross-bill injection, which we talked about a bit earlier. And cross-bill injection, what's that? That's when someone is using a dependency manager with insecure dependency fetching, maybe no signature validation, maybe not even TLS, to inject code into the dependencies when you fetch them. And this injected code will be stored on your development machine or your build server and built into all products you build using that dependency on that machine. And lots of companies would be great targets for that, but maybe a consultancy firm where you can get your malicious code into a bunch of different clients' products at once. And just to illustrate this, we have this nice image here showing a developer build server requesting a dependency from a source somewhere and getting a package back, building something and deploying it or publishing to customers. That's really straightforward. But what if we have some...
Yeah, again with the hoodie.
The hooded guy again.
Yeah.
If there's some evil man in the middle intercepting the traffic and doing some evil stuff, injecting evil code.
You love this, don't you?
Then this package will, of course, get the evil code injected into it. You will store it on your computer, on your dependency cache, and you will build it into your product, which then is deployed to a server or published to maybe an app store and released to your customers. And we're going to show an example of that in Maven in a minute. So most Maven projects download libraries over HTTP without TLS and without signature validation. Signatures are sometimes not even available. And this has gotten better. I think HTTPS is the default now.
Yeah, but most people still use older Maven versions or still explicitly, for example, point out central without HTTP or use third-party Maven repositories, and yeah.
So it can be a configuration issue.
Yeah, it's a configuration issue that affects like 99.9% of all projects, pretty much.
Yeah. So an attacker can inject binaries into your build, either using the man-in-the-middle attack, we showed in the image, or by using some other attack to gain access to your local computer and just putting stuff in your cache. So we're going to show a demo here.
Yeah. Hey, you can. Yeah, there we go. All right. Let's see if this works. So I've got my victim machine over here, and I've also got my attacker machine, which is black, well, green on black, so you see the difference. On my attacker machine, I have two servers. I have a server that is an evil web proxy that will do the actual interference and act in the middle of the process and rewrite the packages that I'm downloading. And I also, just for the sake of it, I start some sort of reverse shell server, as it seems we always do. And let's start here. So looking at a project I've created, I've got a POM file for Maven, and I also got one vulnerable class.java. It's not really vulnerable, but it will become vulnerable. Checking into the files, the project is just a Maven project. It has a dependency on Google Guava, which is a utility library that some of you might use. And the vulnerable class is pretty stupid. It imports tree multimap, a collection from Guava, creates a tree multimap, then it just synchronizes on an object for no good reason. It means the application will not terminate. All right. So normally I would just go into my vulnerable project and I would try Maven clean install. I'll make sure I got my servers open. Hopefully this will work. I'll try to build my project. So I'm downloading stuff from repo.maven.apache.org in this case. Everything seems fine. I had to download Google Guava to get this working, but that seemed to work out fine. So I've built my project. Looking on the attacker computer, something has happened in my my proxy. So I've streamed some files, and then I've also found this, got a request for Guava 1301 jar, starting evil modification. Injects references 1412 classes, and also add an evil file. And interesting part here is that Maven does checksum check. It checks a SHA-1 hash for each file that you download, which is not a security measure, because what I can do is after I've injected into the jar file that I recreated, I just recalculate the hash, and when the client asks for the hash file, I just send the new hash instead. So hash is not a signature because I don't need anything secret to generate this. I just regenerate it. So when we got the request for the SHA file, we're sending the modified SHA back. All right. So let's see. Let's go into the output directory of this. We got just the one vulnerable class here that we compiled, and let's try to run it then. I'm going to add the sorry. I'm going to add the Guava library to my class path, and then I'm going to run the vulnerable class. And it adds some extra text here. It says connecting to attacker port 7500 connected. This was not in the source code, as you might have seen, and also most often these types of software will not tell you it's connecting to the attacker. So this is a bit more helpful. In my reverse shell server, I got a new client here. I can do some stuff. I can execute commands. The thing here is I'm not just running ls as Emil would do. I'm doing something more fun. I've actually injected bean shell into the application or into the dependency, so I've got full control of the Java runtime and can actually run and interpret Java code on the fly here. So since there are probably a couple of swing lovers out there, I could, for example, do something like this with the J option pane. Let's see if that works. And we get something. This was probably not in the source code to begin with. Just to make sure that we didn't compile this in, I'm going to look into the bytecode. So I'm exiting that, and I'm going to look into the bytecode of the vulnerable class. Sorry, I'm going to add this. Doesn't do much. Creates a tree multimap, and then it locks on this object, and that's it. Not much to see there. Let's look into the Guava jar file that I just downloaded from repo.apache something, it seemed. Here we have like a bunch of Google Guava classes, collections mostly. It's huge, this library. Let's see if, oh, there's something happened. But suddenly I also see that the jar file contains something else. It contains this sc TrueSec evil bookmark reverse shell class. That is not in the Google Guava library normally. Also, the entire bean shell is not injected into the jar file. So this goes for, actually this web proxy will interfere if you even download a jar file from your web browser or whatever. It will just try to inject itself in anything. It's somewhat promiscuous. So looking into the tree multimap class though, that was the only thing I was importing. Let's look into that one. This is not easy to read, maybe because it's Java bytecode, but going a bit, just following, so let's see here. If we got something to see. I'm looking for a constructor. I might have missed it. Invoke static. Yeah, there we go. So I've got this init, this constructor for tree multimap, and in the end of this constructor, we got an invoke static for reverse shell.start. So this was the class that I injected into the jar file. So what I'm doing is I'm adding classes to the jar file, and then for each class that was found in the original jar file, I actually inject references using bytecode manipulation to call my class. So each time I import or create any object from the Google Guava library, it will trigger a reverse shell home to me, just due to the fact that I did not make sure I downloaded my library securely. And that was that demo. So the take home here is, all is not lost. You just have to look at how you download your libraries, and you should see what the best practices for your system is. For example, in the Maven case, you should definitely be using TLS to download, and you should also, if possible, verify the PGP signatures that is most often available in the, or at least the Maven central repository. All right.
Okay, so now we know how to manage our dependencies, or how not to manage our dependencies. Now it's time to actually build something, and how do we do that? We do it on a build server, right? That's great, and risky. And again, the big question here is, who has access to this? If you have a build server that exposes a web interface, where you can get all the built artifacts, who can log on to this? Can everyone in your company log on to a build server and get all different kinds of stuff from that, maybe even source code? And depending on what your project is, exposing binaries might not be a big problem, but if you're developing like a web app that's deployed internally, you might want to restrict access to that. And also think about if you're building debug binaries, where you maybe disable some protections, maybe you have extra debug output, you should probably not allow everyone to get access to that. And most build servers, as I said, also expose source code in some way as a way to help you know which build represents which commit or version in your source control system. And when you build on your build server, you should make sure that your tests that you of course have are being run all the time on each build. And if something fails, if any tests fail, you should not get any useful output at all. Nothing that's executable. That's really important. And another thing that can be nice, if possible, try to make your builds reproducible on your build server at least. Meaning, if you build the same source code several times, you'll get identical output. This really helps to verify exactly which version of the code you're running. And if you find bugs later on, you can step back to a previous version and get the same build again, and maybe add some debug features. So it's really nice, if possible. Okay, moving on to the next step. This can probably be run in parallel to the build step, really. The verification step. You want to verify that the output you get from, well, both your build step, really, and what you produce as developers, your source code. You want to run maybe static analysis on this, both on source code and the build output on your binaries, if possible. Depends on which language you're using. And you could use just some basic sanity checks on your build output. For example, check the size of your output binaries. If they suddenly triple in size, something's probably up. And if you're using a separate build step to maybe add obfuscation to a binary, check the output to make sure that this obfuscation really applied. And sometimes, even if you have internal code reviews and static analysis and stuff like that, when you're writing, for example, security critical components and modules, using external verification can really help as well. Using security testing and pen testing. And,
doesn't even have to be TrueSec.
No. Bring in anyone. But this can really help a lot to get new eyes on your code. And we're repeating this a lot, but having good code standards, having consistent, easily readable code really helps a lot with code reviews. Makes code reviews easier, faster, and more accurate. Okay, so you've built your application and you've verified that the output looks fine. It's time to sign it. So what's the purpose of code signing? The purpose is to ensure your users that a piece of software was released by you. It's a guarantee that something was made by you. So then, who has access to your signing keys? And this trust between you and your users is really important, so you need to keep track of this, really have hard control over the keys. You need someone who's responsible for the keys. Because what happens if you lose your signing keys? Or maybe they're leaked online. We saw a while ago that the developer of a popular music app for Android had to suddenly make all the users install a new, seemingly identical application that was released with a new package name and signed by new keys. The reason for this is not certain, but it seems plausible that they somehow lost their keys, maybe. So you might want to avoid that.
Yeah, you don't want to call your customers and say that, I'm sorry, we lost the keys.
No, that sounds bad. So you really need a structured signing ceremony. You need to, and this is a really important step, signing your stuff. So you need a really structured way of handling this with someone who's responsible. And please don't do it on the build server. A lot of people do this. If you sign on the build server, you risk turning it into a signing oracle, which is exactly what happened to HP in the example I told you about before. When they actually accidentally signed some malware, they didn't lose their keys. They just turned their build server into a signing oracle, which is almost as bad. But you can have different degrees of security in your structured signing ceremony. You can store your key in a source code repository. That's really bad. Never do that. You could perhaps sign on the build server. But as I said, that's turning it into a signing oracle. So that's something that should be avoided as well. Signing on select machines. Now we're getting somewhere. This is actually pretty adequate for a lot of projects. And even better, if you just disconnect these specific machines from any network, you have air-gapped specific computers for signing, password protected, and etc. And you should also probably store your keys in a safe somewhere, encrypted. Possibly multiple copies to avoid device getting destroyed or...
Yeah, not just the one USB. You could add it to 35
never.
USB and a CD-ROM and whatever.
Yeah, and of course everyone who's a bit security conscious have armed guards and retina scanners. That's really important as well. No, but I mean there are various ways you can do this. But what should you aim for in a realistic scenario? Signing on select machines should be the bare minimum. You should never go below that. Automatic signing on build servers, it's really common, it's really bad. Okay.
Yeah. I'm going to talk real quick about publishing your app after you've actually built it and signed it and verified it and what have you. Often you publish it somehow. Sometimes you just deploy it to your application server and then you're done, perhaps. If you publish it to an app store, who has the account information? This might seem obvious, but sometimes a lot of people have, and then they have parts of your identity as a publisher. An interesting point would be, do you serve binaries or other files to your website somehow, or your company website? Do you even allow the users, or do you even give the users a chance to download this securely? Do you just publish a binary file on your over HTTP? Then there's no way they can download it securely. So you should probably make sure it's TLS and perhaps add, for example, a PGP signature for the really paranoid to be able to verify it, but at least give people a chance to download it securely. Moving on quickly to the last step, that is actually running the application in your system, whichever system that might be. We often load code dynamically, almost always in some way when we're running the application. Most of the things from the earlier parts where we're talking about third-party library will apply here as well. Sometimes the code is even downloaded. For example, if you hyperlink to JavaScript, you download just random code from somewhere. And sometimes you have applications that have automatic updates. If you do have automatic updates, you need to make sure that those are signed and downloaded securely as well, or we're back to square one. And something you might not think about is you're loading a lot of dynamic libraries often if it's an application, a lot of DLL files or jars or whatever. So you often load a whole bunch of code when your application starts. And code should be verified, as I think we've noticed or mentioned before. So if it's possible in the application case, you should prefer static linkage. And that's not to prevent from someone injecting evil code into the system binary, rather so that you know exactly which version of the library that you're running in your application, so you know that there's no security issues or compatibility issues. And if it's possible, if your system allows it, you should verify signatures. And you should definitely verify script sources. If your application has some sort of scripting or download script, you must verify or at least make sure you have a secure connection to that source. So please stop hyperlinking third-party code. And this goes for jQuery and all those other libraries as well. You might have some premature optimization about, or some dream about download. It's faster for you to download jQuery from CDN or Google, but don't do it. There really shouldn't be a reason for you to do that, because in that case, if you're downloading over TLS, perhaps it's not that big a risk, but just don't do it. You need to know which code you're executing, and the only way you can do that is to actually own the code. But as a little tidbit, as a last point regarding just hyperlinking third-party code, I don't know if anyone has seen this, but a functionality called sub-resource integrity is coming to HTML if you're doing web applications. Probably coming to HTML. It's in a more of a RFC state, and with the sub-resource integrity, you can, to the script tags, to image tags, to even link tags, I think, add integrity attributes saying that the resource should have this SHA-256 hash when it's downloaded, otherwise I don't trust it. So this is going to be really nice, I think. I hope you also think this is going to be nice. You can even protect resources from within your own server. The thing is, of course, this would only work if the actual script tag we're seeing here and the integrity check the SHA-256 hash, if that hash is actually downloaded over HTTPS, because if this page is not loaded securely, then the hash is worthless again, because hashes are not signatures. They are just hashes. So, as a conclusion, you need to ask yourself and go back and look at your environment. Are the machines secure, both your development machines and also your build server and your version control server, etc.? Who has access to code and binaries, because those might be secret. It's very easy to find information from bytecode and even machine code. Who reviews the code? You should at least aim to have internal reviews of all the code you're using if you have some sort of security standard. Think about all the points where evil code can get injected. Probably not too many points. Probably developers' computers and the source code repository and the connections in between there. So, and also make sure that your identity as a signer and publisher is safe. Please do not sign on the build server. There's really no good reason to turn your build server into signing Oracle when it's so simple to sign offline in a controlled fashion. And I think we have, we should have time for a question or two if there's any. Any questions?
Crystal clear.
Okay, we had a question earlier about how many projects actually use hashes, I think, in Maven. And Maven automatically uses hashes, as we've shown earlier. But Maven Central often have I think they require it for new binaries that there are PGP signatures as well, but very few download those signatures, and very few build processes include the actual verification of said signatures. I think I have no idea if this is true, but I think it's in the lower percent, like 1 or 2% of the PGP signatures are even downloaded or per request to download. All right. Well, if there's no questions, then I guess we're done.
We are.
Thank you very much.